Okay. Good morning, everyone. Welcome, and thank you for joining the deep dive on Kubespray. I'm Chad Swenson. I've been a software engineer at AT&T for about the past 7 years. I've been contributing to and running Kubernetes clusters in production for about 2.5 years now. I'm a Kubespray maintainer, and I'm active in SIG cluster lifecycle.
Hi, everyone. I'm Antoine Legrand, software engineering manager at Red Hat, formerly CoreOS, and we'll see what's next. I've been one of the creators of Kubespray and still maintain it today and being very active around SIG apps and SIG cluster lifecycle. So today's session, we try to share a little bit of context of Kubespray and how we make decisions, and Chad will detail each of them, how they translate inside the code. Also, 2018 was, we made quite some achievement, and so we're going to do a small retro and see also what's next for the next year. And this gives you the roadmap. And to finish, Kubespray, there is no company behind, it's just a community, so it's good to see who's behind Kubespray too. Okay, so Kubespray started with Kubernetes 1.0. It's one of the oldest projects in the ecosystem. So 2015, one friend and ex-colleague, Asmain Kalouche, just was always on the edge of every technology. He came to me and made me a demo of Kubernetes. I was like, whoa, that's amazing. And now we were just strongly believer that Kubernetes is the future in a large organization. And we started a small campaign to convince everyone we need to run that in production. But to be honest, we failed to convince anyone. We talked to product, we talked to DevOps, because the main answer was okay, that's nice until you have a cluster, but how we get there? It's too hard to maintain, it's too hard to manage. So we didn't stop there, and this is how we decided to create Kubespray, to make it easy to install and manage cluster. So that was the starting point. And inside this mission, because we were for our own usage, we had some goals. One was not to deploy proof of concept. We really want to deploy to production. So one core goals of Kubespray is to deploy production readiness cluster. Other part is always focus on bare metal first. That was our environment. We had data center. So always bare metal, no cloud feature. And the last one, composable. You can imagine 3 years ago, we didn't know what's going to happen. That was our only things we know. We didn't know what's going to happen. Which network plugin we're going to use, which container engine will be there. It was Rocket, Docker, and so on. So we decided to add that on one other goal, to be able to change over time when there is new technology going on. So I will let Chad to go through each of these points and explain how in Kubespray we implemented this.
So in Kubespray, we define production readiness by these 4 tenets: high availability, security, maintenance, and observability. This is the same list of tenets that Antoine's followed since the beginning of the project. These goals just drive our decisions on Kubespray, especially when the Kubernetes community and containers in general are changing and evolving so rapidly, and there's always going to be something new. We want to make sure that we are providing a production-ready experience, despite all the options and trying to organize the chaos. So high availability, we apply to 4 different areas: nodes, etcd, the Kubernetes control plane, and cluster services like cluster DNS. And so what does it mean to have an HA node? Well, the nodes do have to keep working. So the Kubernetes components that run on each node need to have guaranteed resources, be it with quality of service class that you put the components in, the resource reservations and limits that are, and also we've introduced priority class once that feature became available, which gives you a priority in scheduling against other pods and workloads in the cluster. So you have these controls in composability over all of this as well, because there's many different use cases for Kubernetes, and different clusters have different needs out of the Kubernetes components. So we have some sensible defaults for all of these, but we leave it configurable for the user. And also different types of node, and just describing the topology is really, really easy with Kubespray, just Ansible in general. And that gives you even more flexibility in tailoring Kubespray to your use case. Another thing that I've done just some work on the side, haven't pushed a PR yet, is Node Problem Detector, which gives you ability to define these custom detections for really anything on a node. It has like a log scanner, and you can also even write custom scripts to write your own plugins for it. And you can interact with Kubernetes API to respond to any of these detected problems, and even write self-healing recovery controllers. I don't have any of that in Kubespray yet. I've been experimenting with that on the side, but expect probably something coming in 2019, or will be introduced in the Kubespray. So etcd, this is actually the easy one to make highly available. It's Raft-based, so if you're familiar with Raft, you don't want to use an even number of nodes because you're increasing your quorum size without actually any true benefit, no extra fault tolerance. We actually have a pre-check for that. If you try to create a cluster with an even number of etcd nodes, will prevent you before proceeding. And it's HA by default with 3 nodes, because 1 is an HA, obviously. You don't want to do 2. And then 3 is the minimum for HA. And the other thing that makes high availability easy for anything that's accessing etcd is that it has this smart client feature where you can basically provide a list of endpoints and credentials to your client, and the client will resolve all the load balancing and failover just internally without having to depend on any external source of LB. The control plane, so this one's very contentious, and it's still very contentious in the SIG cluster lifecycle community, the SIG that Kubespray is a member of. Kubespray offers a variety of options and ways to plug in with load balancing and HA solutions for the control plane, the Kubernetes API server. One common debate is something like keep alive D, which would be a proxy that runs on every single node, and basically kubelet any other components that need to contact the API server, just go through that local proxy, and that's load balance across potentially many API servers. Or Nginx, you can set up an Nginx daemon on every node to do something similar. Kubespray currently has, there's trade-offs to both of those with this proxy approach. Kubespray currently has Nginx implemented, has for quite a while. There's been some debates still ongoing about whether we should implement keep alive D or not. There are some benefits, but also it won't be, in some scenarios, it won't be as flexible for every type of environment. So that's the main reason Nginx was picked first, but we may continue to do work on keep alive D as well. And the community is progressing towards some sort of kube ADM HA solution. There's still a lot of discussion around that, but pursuing a path forward. And Kubespray will, we are actually using kubeadm by default now, and will benefit from any of the features or best practices that were implemented into kubeadm. And then you also have this other use case for high availability in your control plane, which is external access. So something user using kubectl or any other controller that accesses, or code that accesses your cluster from outside of it. And so you have a few options here, and it really depends a lot on your infrastructure. External DNS is a commonly used one. However, Kubespray will integrate with whatever solution you have. It's quite easy to set up all of the PKI to assign your load balancers and DNS names just through the Kubespray configuration. And So we can essentially integrate with whatever option you have there.
So quickly to go back to Kubespray, the solution we have, and only one solution for now, is the Nginx. So on each node, we install Nginx proxy that is configured to load balance to every master, and the kubelet just reach locally this Nginx. So this is now in Kubespray how we achieve availability for the master from the node. But as I say, in the future, we're going to align with whatever cluster lifecycle decide on that.
And also, if you do have external DNS or something as an option, you can integrate that very cleanly with Kubespray and use that across your cluster for both internal access to the API server and external. It's actually a recommended practice. That's what I personally do if you have that option. So the cluster services are basically any pods that are really Kubernetes components themselves to a degree. So a good example would be the cluster DNS. And we need to make these highly available as well. So one way to do this, I mean, it's a lot easier because we're in Kubernetes land at this point. So Kubernetes has a lot of nice features for HA built in. One thing that we take advantage of is the cluster proportional autoscaler for our DNS replicas. And we use this for both kube DNS mode and core DNS mode. Core DNS is a new default, by the way. And it basically, you can define how many replicas of your DNS pod should exist based on how many nodes are in the cluster, how much CPU capacity is in the cluster. There's a few configurable fields. And this works quite well because as the cluster grows, the strain put on these cluster services grows as well. So you want to make sure it's scaled proportionally. We may also add vertical pod autoscaling, which gives you the ability to adjust the resource requests and limits of a pod dynamically. It's still an alpha feature, and there's a couple of things. It's less like recreate the pod because those fields are immutable on a pod. But we will look into that and probably adopt that for some of these cluster services as the feature matures. So security, very important to Kubespray as well. So RBAC is on by default, and if you don't know what RBAC is, it's an authorization mode that's built into the Kubernetes API server. It's role-based. So you got you've got components that use RBAC, and you can also create your own custom roles and bindings for users. We also have configurable authentication modes, webhook authentication, just token authentication, basic auth. You could use OIDC is also supported. So you can plug in with whatever existing authentication system your organization uses. Pod security policy. Pod security policy prevents pods from accessing features on a host that could potentially compromise or impact that node. I recommend turning it on. It does make things a little more complicated if you're not used to the feature. You have to definitely make sure that any pods that require special privileges, because they're part of the cluster themselves or they have some special use case, are trusted. But you can grant that through RBAC, and you configure all of the which privileges different users are allowed within their pods. And so, lastly, we also have individual PKI for every node. So if you need to renew or revoke a cert in case a node or cert is compromised, we've taken that extra precaution just to make that easier to do because each node has its own client credentials. So maintenance, another tenet. It's very important to us. We have gone to great lengths to ensure some of these features still work across all of various versions of Kubernetes and etcd and other components that were not necessarily designed with upgrade in mind, especially not automated upgrade, but a lot of workarounds were required to keep this working and will continue to be. It is getting better, though. The community is looking for more repeatable approaches going forward. There's some discussions in the Contributor Summit on Monday revolving around that, so there'll be some interesting developments there. Scaling a cluster, adding some additional worker nodes to a cluster. removing nodes or removing an entire cluster. These are all features of a full cluster lifecycle that Kubespray supports. Backup and restore. So we do currently take etcd snapshots before an upgrade is performed, just in case something catastrophic happens, you need to roll back. And expect some improvements here in 2019 as well. We'd like to have some native options for something like Heptio Arc, so you can get much more fine-grained control and integration across your backup tools in Kubernetes. Just a list of some of the Ansible playbooks that provide these features. You have cluster, it's for installing a new cluster or reconfiguring a cluster. You have upgrade cluster, which performs a graceful upgrade in a rolling fashion. The way that works is it will perform an upgrade on a configurable amount of nodes at a time. I think the default is 20% of all your nodes. And it'll first drain them to make sure all the pods, workloads running on those nodes are moved to other nodes in the cluster. Then it'll perform the upgrade, and then it'll uncordon the nodes, which draining also cordons your nodes. But then you uncordon lastly, so once the nodes are fully upgraded, so that you can return them for scheduling additional workloads. And we have remove node, reset, somewhat self-explanatory. I've talked about those a little bit. If you want to remove an individual node, you can use remove node. Reset is for uninstalling all of the things that Kubespray installed. And observability. And this is another area that we would definitely like to get better at and plan to. We currently have metric server as an optional add-on. And we don't have really many default integrations other than just what it provides to a user by default, but it is there. It is an install option. In 2019, we'd like to revisit Prometheus. There were previously some versions of Prometheus within Kubespray. Those have all been removed by now. We would like to use the Prometheus operator and figure out some ways to provide some default configurations for the operator that would make sense or could be tunable enough for users that are using Kubespray. So that'll be interesting because people need a lot of different things out of Prometheus, and it very much depends on how you're using Kubernetes. But we'll try to provide some, reconfigurable but sensible defaults.
Yeah. Oh, I think observability is quite a new dimension in Kubespray in terms of production readiness. So we are not yet there, but with the maintainer, we agree this is something we want to add, say, alerts and all the configuration around observability of the cluster.
And then lastly, we have some various dashboards that you can use to monitor the status and health of your cluster Kubernetes dashboard. And some of the monitoring tools have their own dashboards as well. OK. And next, another goal of Kubespray after production readiness is we're bare metal first for on-premise scenarios. So what does it mean to be bare metal first? Well, we want to make sure that Kubespray works well on bare metal. There's a few reasons why. One, it was one of the original use cases, and that's one reason many people come to Kubespray. Also, if you need to, well, if you target bare metal first, a lot of the cloud providers are also easier just with the model that we have, because bare metal is a good fit for Ansible, because SSH is the only protocol needed. You can use SSH on any distro. And the idempotency of playbooks can account for variancy across different OS images. So just because you have multiple hosts, you could have 2 hosts provisioned, it could be the exact same operating system, the exact same hardware. They could look completely different, and we want to be able to target that use case. That's a very common use case. So the way that works is Ansible will first check to see if a change is already in place or installing a package is already in place before attempting to install it, those types of things. And so we also want to make sure that all of our OS packages are tunable and can supplement what's already in place, or if it's not there. And again, so if you target bare metal first, you get a lot of benefits with other types of infrastructure providers, because you've really solved a lot of the hard problems that you may not have had to solve in your cloud provider. But we do support. We run on public cloud, private cloud, bare metal. Next, I'm going to talk about, or Antoine's going to talk about composability.
So I will detail it a bit more there because there is a lot of work on progress. So what means composability? It means as a maintainer, we don't want to make decision about what kind of technology you want to run. So you can choose your cluster, like your cloud provider, either on bare metal. You can choose the operating system you're going to use, the network plugin, the certificate management, if you want to use Vault or OpenSSL, the container engine, so Docker, Rocket, Containerd, Cryo, etc. And also, we have like 2 modes to deployment, kubeadm and the Kubespray native one. So I think this is like also one of the reasons it's very different from any other installer. But so many things look nice there, but in practice is a complete mess to test and maintain. So all of this, like, it translates by different paths in the code. So if you choose this OS, we're going to trigger this role. If you choose Containerd, we're going to trigger this role and not this one. So you can think there is like a lot of paths to test. Like it's not maintainable at this point. So we decided to review all these options and try to clean up this, because this last goal, it's in complete conflict in production readiness. If we can't test, if we can't maintain it, we can't ensure quality of releases. So we have an issue, and it's still open. So the discussion is ongoing. If you have any opinion about any of things we should keep, just join before we remove them, because this, I think, quite important decision to make. So far, we agree on this point. So on the DNS part, we have core DNS, kubeDNS, kubeDNS, DNS mask, core DNS dual, and we decided to just keep the last one, just core DNS. The deployments, I say we have like the native Kubespray one and kubeadm, and we decided to keep only kubeadm. Install mode, this is for the daemon. Let's say etcd. How you install etcd? You can choose to spin up a container. Is your container with Rocket? Is it with Docker, Containerd, or is it a binary with a systemd? Like, there is multiple things. We're not sure which one we're going to pick, but we're sure we want to pick only one, because it doesn't make sense to maintain all of them. In the end, for the user, you don't have any pro to have this choice. And set management, this is more because we didn't have no maintainer, so maybe Vault will come back, but for now we have been removed it. So, and I think also this is not something, especially there is etcd ADM coming, and I think this is not something we should. This is something we should work with C cluster lifecycle and not inside Kubespray. For the operating system, for the network plugin, for the cloud provider, we decided to keep them all, because this is clearly not a choice of the maintainer to make.
And we definitely want this to be a community discussion. You know,
Yeah.
you are a great community.
So there is the issue. The slide will be shared. So if you have opinion, just go there and share with us. So this, now with all this choice, this look like this. It's like 200 paths, and with some improvement in the CI to just correlate things together. Maybe we don't need to end-to-end test everything. Just like the OS, does it install well with Docker? And then we don't need to test for all installation. But even if we test all, this is like much more clean to maintain. So yeah, I wanted to pause on that because I had some question about why did you remove Vault, why we have less choice, but this is to improve the overall quality and to be able to move forward for next year. Speaking of next year, so maybe before we talk 2019, a little bit show, Charlie, if you want to.
Okay. So just year in review, it was a very big year for Kubespray. Most notably, recently, we released version 2.8. And in 2.8, we've deprecated the kubeadm deployment method. I mean, sorry, we deprecated the non-kubeadm deployment method. And in version 2.9, non-kubeadm will be removed entirely. Point out, though, we do plan to retain support for upgrades from non-kubeadm. And if you see any issues with that or anything else with this transition, please report it. And so next, our Kubespray repo moved to the Kubernetes SIGs GitHub project. Kubernetes SIGs is where all of the SIG-owned projects in Kubernetes are being, if they're new, they're being created there, and others are being transitioned to there slowly over time. We were previously in Kubernetes Incubator, and the Incubator program was retired probably, almost 2 years ago. So it was a good decision. And we're just trying to stay as closely aligned with SIG cluster lifecycle as we can anyway. So again, if you see issues with that, any broken links or any integrations that have failed, please report it. We added a variety of new network plugins: Cilium, KubeRouter, and Multis. Those last two are interesting because they're fundamentally different from the others. KubeRouter is actually also a kube proxy replacement, and Multis allows the user to select which network plugin they'd like to use. So those provided some fun challenges. There's only 3 here on this list. We implemented tons and tons of new Kubernetes features because you and the greater Kubernetes community is just keep killing it and putting out new features and things that Kubespray users absolutely need. So we've continued to integrate pod security policy, priority class, dynamic with these types of things. And as Antoine was mentioning, we moved many of the non-core components, some add-ons that were not used much, and we're also distracting from our main goal of production readiness. And lastly, we also introduced CRI-O as a new container engine, and also restructured the way container engines are installed in general to pave the way for Containerd and others. Do you want to just run that?
Yeah. So yeah, as I said previously, observability very important. So we'll get out of the box very sane default to hook to alerts and on your system. One thing that is not there, we engage work around deploying on RM and Windows. We've been shifting a little bit the focus to install on kubeadm only, but it's definitely going to come be released and pretty stable for next year. So in one cluster, we expect to be able to have an hybrid architecture automatically without configuration. So since now we are sponsor officially SIG cluster lifecycle, we're going to work more closely with them and integrate decision made there. So, and also the CI. So one of the ideas of the CI is when there is a kubeadm merge, let's say, or every 2 hours, we're going to run this new kubeadm release, or the master branch, with Kubespray and say, yes, it's still working, or no, you made something that broke Kubespray. So we get like this signal back to the kubeadm CI also, so we make sure they don't release something that will break Kubespray, and they know better this higher the quality of kubeadm also. There is component config, bundle, and last one, it's etcd. This is, I think, still a cap, but it's been approved by the SIG. It's a way to manage and deploy etcd. A little bit like kubeadm, but for etcd. So as soon as it's available, we're going also to replace our etcd installation with etcd. So the last bullet next is decentralized orchestration, meaning right now we have like one Ansible node to deploy everywhere. And every time we need to do an upgrade, we go back and do again. And we had this idea from the beginning that at some point it's maybe not required. Let's say, why should a node know about other nodes? Can't it just configure itself? Can't it just upgrade? Just download the latest hypercube. So there is a lot of thinking around that. I think we are quite far, but we really want to tackle this because it enables automatic upgrade or at least very easily just say, oh, I want the next version and just wait. It will make it much, much faster at scale, because if each node are independent, if you spin 10 node or 1,000 node, it will be the same. You just maybe have 20 working, 40, but you don't have to wait for the 1,000 to work to end the script. And same for auto-scaling. If each node are independent, you can know if you're on the cloud, configure things, say, oh, I bootstrap my node, I would just start this Kubespray container, or still need to be determined how we're going to configure, but that's the main idea. And that's probably going to be for Kubespray 3, because see what's going, how we be able to switch to this architecture and upgrading from previous cluster. So that's, I would say, some of our ideas, but we're very open and also accepting much PR. So if you have difficulty of anything or things that is more important, just share. We have a big weekly meeting to share such ideas for the future.
So who here uses Kubespray? Just show of hands. Oh, very cool. So Kubespray is used by, pretty much every size of business, startup, small, medium, large enterprise, and even some governments I found out recently. It's a common option because it does work in so many different scenarios, different types of infrastructure, and with composability to tailor Kubernetes to your use case. It supports upgrades, another great reason why a lot of people pick it. It's easy to contribute to is another strong reason, in my opinion. It's why we've had so much success with it. Open source projects use Kubespray for their CI and general automation. And there's even a number of Kubernetes distribution vendors that have built products on top of Kubespray and use it for their cluster installations. And Kubespray, it's a completely community-driven project, completely free and open source, always has been, always will be. Yeah, another strong reason to pick Kubespray. So just a little bit of stats here. I won't go through all of them. Some highlights. In 2018 for our GitHub repo mostly. So there are 4,000 unique users that participated in by any kind of contribution. We had 309 unique contributors that actually created pull requests. I think now we're around 10,000 unique visitors per week to the Kubespray repo page on GitHub. 4807 stars. And we're frequently just by commits, if you look at dev stats, we're within the top 2 most active repos, usually only after Kubernetes/Kubernetes itself. Almost always within the top 5, and we're actually competing against 3 other repos that are mostly just commits generated by bots. So it's a very active and wonderful community. So we are growing fast. Most of the activity more than half of the activity of over the entire lifetime of the project was in the past 6 months. Was very strong past 6 months. Very active Slack channels. Please join them. And there's no company behind Kubespray. It's completely community driven, and it always will be. And there's no single entity that controls it. It's the community. And
I think this adoption is part of the realization. It's part of the adoption of Kubernetes, and I think many hit the same issue I hit. It's still 3 years later, it's still hard to install Kubernetes, and Kubespray gave this ability to manage it. So as people discover Kubernetes, and they try to find solution to install it and manage it easily.
And lastly, who here has contributed to Kubespray? If you want to come up on stage, you deserve a huge round of applause. Thank you so much. We can fit a couple.
Any other contributor, just come on stage if you have.
Or to the stage. Yeah. Don't know how the weight limit on this thing. And then lastly, we have maybe a little bit of time for questions. Looks like we are just right on the dot out of time, but 1 or 2 questions, anybody? If not, just come to us afterwards.
I do have a question.
So my main question is, I've seen a lot about Cluster API lately, especially at KubeCon this year. I'm curious to see where Kubespray is going to go with that.
It's in our roadmap. There's currently an SSH provider for Cluster API that Kubespray could leverage. What that's going to look like will be interesting because there's some overlap with some of the other providers that we may not have to use the Kubespray version of that automation. But we definitely plan to support that because there's just a ton of power. If you haven't gone to a talk on Cluster API, I would highly recommend that.
Was that a question? Okay, go ahead.
So my question is, I contributed for a while, and after you make a commit or pull request, there is usually a bot. So what's the testing process or the CI process that goes through to verify if something is valid?
So on the CI, we do end-to-end tests. So we actually deploy a cluster, and we create resources right now on Google Cloud. So it's expensive. So the process is someone need to review and accept this to be a test. So I think the command is like CI check this from one of the maintainer, and after this, it will be able to trigger the CI. So if no one have been this, you can just ping any of the maintainer or go on Slack, and don't hesitate to
And this is another thing that as we start using more of the SIG cluster lifecycle and Kubernetes project automation, we'll probably replace some of those existing magic words and bot commands.
Other question?
I have two. You said about cost. Who paid the bill before you enter in the SIGs? And do you see Kubespray as the default distribution for Kubernetes?
There have been discussions around that. But Kubespray is really, from the SIG cluster lifecycle and community perspective, is the tool that ties all the other tools together.
So yeah, I think there is like in the community and under the SIG cluster lifecycle, there's quite a consolidation around tools. And we have KubeADM, KOps, and Kubespray right now.
Kind as well for testing.
And I would say KOps for now focus. There is like more or less the same goal, but with different focus. So yeah, I think this is like the three main things that's going to happen as a distribution. So.
We're a couple minutes over, so I think we'll end it formally here. If you have more questions, feel free to come up to us. But thank you so much for coming.
Thank you.